Hi folks, today we're going to talk about data distributions as functions. So your algebra knowledge from the past is going to come into play here. A few things we need to discuss before we get going is the idea of domain. Domain is the set of all x values in a function. Likewise, we need to talk about range. Range is the set of all y or function values in the function. And then additionally, we need to talk about a function. In order for a relationship to be a function, you can only have an x value mapped to one y value. So you can't have in a table a 3 for an x and a 7 for a y, and then a 3 for an x and an 8 for a y. So every x value can map only to one y value. This would not be a function. So let's begin and let's discuss the bar graph that you have on number 1. It says let f be a function that maps the method of travel to the school to the frequency of responses of that mode of travel. So we're mapping to the frequency. The frequency is over time. This is the mode of travel. So we are literally writing these labels along the x-axis and along the y-axis to help us understand what the x's are and what the y's are. A bar graph of the responses to a class survey is shown below. It says explain the meaning of each of the expressions given the function notation below and the context of this scenario. So in the context of the scenario, we're just polling students to determine what their mode of travel is. Do they travel by car or bus, or do they walk? So, keeping in mind that our mode of travel is along our x-axis, those are right, f of x. These numbers here indicate the frequency. Those are the y values. So just kind of an interpretation of what is happening. So f of car equals 2 means car is the mode of transportation, and 2 is the frequency of responses of people who chose car. So 2 responses chose car. So I want you to pause the video and try to write a representation in the context of the situation for B and for C. Pause your video and write your answer. So you should have said that 35 responses of students chose buses and then 4 responses chose walking. So that's the way we read this f of x equals y. F of the mode of transportation equals the frequency. And typically those y values or those function values are going to be the frequency. Number 2. Number 2 says, a survey was taken of the 80 students enrolled in the Introduction to Statistics course at a local community college. One question asks students how many semesters they had completed at the community college. Describe the domain and range of this data distribution. So the question is about semesters completed at the community college. And then we need to describe the domain and the range. So again, if I were going to put this in a frequency bar graph, my domain would be what I'm measuring, and then my y value, my range, would be my frequency, right? So what I'm asking about is the number of semesters they had completed. So my domain may say something about the number of completed semesters. Number completed semesters. It may look something like 1, 2, 3, and so on. My range would be the frequency of those responses. So along the x-axis, I would have bars for the completed semesters, and then the range along the y-axis, I would have the frequency of those responses indicated. So part B of the same question says one student remarked that this data distribution could not be represented by a function since many students in the class were in their first semester at the community college. Do you agree or disagree with the student's remark? Explain your reasoning. So what the student is claiming is that the data could not be represented by a function. And their reasoning is that the students in the class were in their first semester of the community college. So do you agree or disagree? Pause your video and give an explanation for your reasoning. So perhaps you agreed or perhaps you disagreed, but hopefully when you explained your reasoning, you were able to kind of circle back around to looking at the way this should be in a bar graph. So perhaps we had number of semesters along the bottom and the frequency along the side. Perhaps 2 students were in the first semester and maybe 1 student had completed their second semester. Maybe 3 had completed their third semester. But the argument here was that the data distribution could not be represented by a function since many students in the class were in their first semester at the community college. So if they're in their first semester, they hadn't completed any semester previously. But we can always take care of that by putting a 0. So a lot of students perhaps were in the 0 column. So when x is 0, perhaps y is 3, and I'm not double dipping when it comes to mapping an x value to multiple y values. I just have 0 and then I have the frequency. So this definitely is still able to be represented as a function. So let's turn the page. Part C says, another survey question asked students their favorite car color. Let f be the function that maps the color to the frequency of responses for that color. So we're mapping color to the frequency of responses for that color. We're going to analyze each of the following, A, B, and C, each of the following expressions, and we're going to explain whether or not it is a correct use of the function notation in this context. So keep in mind that the color is what would be along the x-axis, and the frequency of responses would be along the y-axis, also known as f of x. So inside, we should have a color, and outside, we should have a frequency. So looking at part A, do we have f of a color equal to a frequency? The answer is yes, we do. So this is correct. And we can say because red is a color and 10 is a frequency. So pause your video and try part B and part C, remembering that x should be a color and the what it equals should be the frequency. The y should be the frequency. So part B. Part B is incorrect. F of 20 cannot equal blue because 20 is not a color. And the color was supposed to be along the x-axis. The frequency was supposed to be along the y-axis. So B is incorrect. C is also incorrect. At first glance, it seems like color is a color, which is actually not true. But also, white is not a frequency. So we needed f of a color equals a number. So this is also incorrect. So this kind of just gets us understanding the difference between domain and range and how you incorporate those in function notation. So let's look at number 3. Number 3 says the dot plot below shows the travel time to school rounded to the nearest minute for 42 students. Notice along the x-axis we have travel time to school in minutes, and along the y-axis we have frequency. For example, no students chose that it took them no minutes of travel time to get to school, which would make sense. 1 minute to travel was listed as the time for 1 student. 2 minutes to travel was not listed. 3 minutes to travel was indicated by 1 student. 4 minutes to travel was indicated by 1 to 3 students. So 3 students required 4 travel minutes to get to school. So part A says complete the frequency table for the values in the dot plot. So again, when the value was 1, the frequency was 1. When the value was 2, the frequency was 0. There was no dot along here. When the value is 3, the frequency is 1. When the value is 4, the frequency is 1, 2, 3, and so on. So pause your video and complete the frequency table all the way through the second table. You'll notice that the frequency is pretty high right here. It kind of tapers down. It has another few times where it goes up, but then in the end, it does have a lot of frequencies of 0. So in your table, you should have quite a few zeros in that second table. So let's turn the page, go to the right. Our notes today are all about representing these frequency bar graphs as functions. So part B says, let f be a function that maps each travel time to school, rounded to the nearest minute, to the total number of students who reported that travel time. Graph the function f on the coordinate grid below, and how are the dot plot of the data and graph of the function f similar? How are they different? So our task is now to plot those points from the table, and I'm going to connect them with a curve expressing my function. So there was no student that chose 0. When the value was 1, the frequency was 1. When the value was 2, the frequency was 0. When the value was 3, the frequency was 1. When the value was 4, the frequency was 3. Notice that I'm not putting 1, 2, 3 points. I'm just putting the point 4, 3. When the value was 5, the frequency was 4, and so on. So I'm going to go through and I'm going to plot all of these points, and then I'm going to connect them with a curve. So pause your video, finish plotting out all of your points from your table on the left, and then connect them with a curve. So here should be your function f. This function maps each travel time to the school rounded to the nearest minute to the total number of students who reported that time. So all we did was plot our points from our table, and then we connected with a curve. There's a lot of ups and downs in this table, or in this graph, and then you'll notice towards the end a lot of the frequencies were 0, so we have kind of this constant line until we hit that little bump, and then another little bump at the end. So here is our function. We'll notice that it passes the vertical line test, which is a way to test for functions in graphs. You'll notice that if you put a vertical line through the graph, the function should only hit that vertical line once. So that means that the function has passed the vertical line test and it is a function. So part C says, what is the value of f of 5? And what does it represent in this context? Remember that 5 is an x value, so that's along the x-axis, and that's an amount of time. So when f of 5 is being found, 5 is your x value. If you go up right here, here's that point, and all the way over, that's a 4, a frequency of 4. So f of 5 equals 4. And what this means is that 4 students chose that it took 5 minutes to get to school. 4 students reported traveling 5 minutes. Part D. What would you use function notation to express the statement, 2 students reported that it takes them 20 minutes to travel to school? So keep in mind that when you're writing f of x, this is an amount of time, and what it equals is a frequency. So if we say 2 students reported that it takes them 20 minutes, 20 is an amount of time, so I would say f of 20. And the frequency is 2. 2 students chose that. So we're going to move on to part E. Part E is a little bit more elaborate. Part E states, suppose that you group the data into 5-minute intervals as shown in the first column of the table below. Use the ranges of travel times here to complete the frequency column. Now there is one that is missing, and right in between here, there should be from 10 to 15. So we'll have another number that goes here as well. But in order to count those, it would be really nice and easy to look at your table. So when you look at your table for times 0 to 5 minutes, not including the 5. So 0, 1, 2, 3, and 4. and our table. That's happening